In this video, I'm going to show you a power station. It's from the brand BLUETTI, and this is the alternating current 70 model. The idea is to put this power station to the test to see if it can actually be useful to take it to work, to the job site or wherever we are off the grid, and be able to connect our tools to see if we can do carpentry work away from the power grid. The capacity of this model is 768 wattage. In theory, that means if we connect a tool that uses 768 watts, the battery will last for 1 hour if we use that tool continuously. We can connect tools that use up to 1,000 watts, and there's also a power lifting option that allows us to connect devices that go up to 2,000 watts. However, when you reach 2,000 watts, what this machine does is lower the voltage a bit, so the performance is not the same. But the good thing about that is it still allows us to plug in tools that use more than 1,000 watts, just with less performance. We have 4 USB ports here, USB-A and USB-C, and we also have 2 alternating current outputs. This is important. If you're in Chile, you'll need to buy these adapters. They're called Shuko. You can find them at any hardware store. You just put it here, and then you'll be able to plug in. Because this type of plug isn't compatible with the ones we use here in Chile. And the plug that comes with the charger is also one of these Shuko, so we would need 1 or 2 of these and 1 of these. So we can charge it directly from the house's electrical network. Here in Chile, we use 220 or 240 volts, and of course, this model has to be the one you buy. It also has to be compatible with the voltage you use, because in the United States, you use 120 volts. Here in Chile, we use 240. And we can also use solar panels, which I think is one of the interesting things about this station. The panels are a separate accessory. You have to buy them separately, but this model does include a charger to connect to the power grid, and it also comes with this plug. To enter the menu, we have to hold down these 2 buttons. Here you can see section 1 of the menu. We move forward with this button to section 3. Oops, I went past it, going back to 3. And here you'll see these 2 symbols appear. This is for fast charging, and that moon with the Z is for silent charging. If we press this button, the 2 symbols disappeared, which means we're charging normally. Then if we press it again, the little moon appears, which is silent charging. Less power goes into the station, it takes longer to charge, and then there's supercharging, which is this one. There you can hear how the fan starts to sound a bit louder, also because more wattage is coming in. And here you can see almost 1,000 watts are going into the station. And the charging is super fast, 0.1 hour, which is about 6 minutes. These connections are pretty standard. You can connect the solar panels you have available right here. And once these cables are connected, we have to connect this to the station. Here I have the panel located. This is a 120 watt panel, and obviously we have to try to point it right at the sun. The panels should be clean. The typical things that are necessary in a solar panel to capture as much light as possible. Up here we connect the panels. We're going to see right away how many watts we're capturing. Let's see. We're at 80% battery capacity, and right now we're getting 96 watts, 97 watts. The sky is a little cloudy, but we're still getting good sunlight, the maximum we can expect with a 120 watt panel. At least in the tests I've done with this brand, with BLUETTI, I've managed to get close to 100, but not much more than that. Down here, it tells us how long it will take to fully charge the station at 96 watts input. That's 1.6 hours, which is 1 hour and 40 minutes. We should get from 80 to 100. For this station, we could connect up to 500 watts of solar panels with 500 watts of solar panels. We should be able to charge the station in 1.5 hours or 2 hours with good sunlight, using these 120 watt panels. I think we would have to calculate that, but I imagine that in about 6 or 7 hours of good sunlight, we could charge the station. So keep that in mind while we're charging with the panels. There we had almost reached 100. There we reached 100. We can also use the station if we activate the direct current here, All these USB ports turn on, and we can also use the alternating current here. With these two outlets, that's when the inverter that comes with this station starts working. Here it mentions what I told you about. Up to 500 watts can come in with solar panels. Now, it's not very practical to carry 500 watts of solar panels out in the field. But if you have fixed panels on a recreational vehicle or in your own house, you can connect them directly there as long as you don't go over 500 watts. Let's wait for the station to keep charging, take advantage of this good sunlight, and then we'll do the tests. I have a really powerful drill here, and also some other things. There you can see the sky. With a few clouds, you can see the sun behind them. Let's see how much is coming in. Look, even though there are quite a few clouds, it still dropped, but we're between 180. I want to show you here how a compressor works, which I always carry in my car for emergencies. How can we make it work with this station? By plugging it in here. In this 12-volt socket, we need to have the direct current activated. And we turn it on. There you could see that 110 was coming out and 105. 106 was coming in. So almost balanced. We were practically not using the station's battery. That's always in an ideal scenario, right? With plenty of sun at a certain time and with a device that doesn't consume much electricity. So don't think that with just the panels, you'll be able to use them all day. This season, we have a window of just a few hours of good sunlight where we have to take advantage and charge it. But in reality, it's rare to achieve that balance in other contexts. If we want to charge the station from the car, we have this adapter that the station does include. We have to plug this into the car, and then the other end here, where the panel input is, thank you. Let's do the test. I'm going to turn on the drill and check here to see how long the battery will last. With continuous use of this tool, this information is quite useful. Always keep an eye here. From this number for the next test, we're going to charge the station to 100%, and we're going to connect a device until the battery is completely drained. And that way, we'll be able to see the real performance in practice. What the station does when we connect the panels in the grid is to reduce the consumption from the grid and compensate it with what is coming in from the panels. A good way to save a little bit of electricity. Let's see. We finished the test. We asked ChatGPT for a little help with the numbers. The vacuum cleaner consumed an average of 900 continuous watts and ran for 46 minutes. That gave us 90% of the total capacity compared to what BLUETTI advertised, meaning instead of 768, we got 690 watt-hours. I think that number can vary depending on whether we use devices continuously with different wattages. But you already know that with a vacuum cleaner that claims to use 1,000 watts, it drew 900 watts, and it lasted 46 minutes, which gives an autonomy or a percentage of 90%. I hope you liked this video, that it was useful for you, and that's it. See you soon in the next video. Sending you a hug. Bye.